Welcome to CAD and Sorcery, fellow designers. I thought this would be the perfect time to talk about SOLIDWORKS drawings and help newcomers learn the basics of creating a drawing from the 3D models. Keep in mind that this video will only scratch the surface. To truly master drawings, you'd need more hours of training to explore everything they offer. Topics like custom drawing templates or advanced features such as whole tables won't be covered here. Instead, this video is aimed entirely at beginners. By the end of this video, you'll know how to insert a 3D model into a drawing, create any views you need, add annotations, and finally export your drawing to PDF so you can share it with others. So without further ado, let's jump right in. There are several ways to start a new drawing in SOLIDWORKS. The most common is to click the File drop-down menu and select New. From the dialog that appears, choose Drawing. Next, you'll need to pick your sheet format and size. By default, SOLIDWORKS shows only the standard formats. But if you uncheck the box here, you'll see a wider range of sheet format and size options. Once you've made your choice, you can check the width and height of the sheet in this area. When you're done with your selection, click OK to continue. You'll now see a blank drawing sheet on your screen, complete with a border and a title block in the bottom right corner. You'll also notice the Model View command automatically appears in the PropertyManager, but for now I'll close it. Navigation in a drawing is very similar to what we've seen in assembly and part documents. The main difference is that there is no third dimension here, so pressing the middle mouse button will pan the drawing, whereas in assemblies and parts it will rotate the model. You can still roll the middle mouse wheel to zoom in and out. If you hold Shift while rolling the wheel, your zoom will feel smoother and more controlled. As you can see, working in just 2 dimensions makes navigation much easier than in a 3D model environment. You'll also notice the familiar heads-up view toolbar at the top of the sheet. This gives you quick access to useful commands such as zoom to fit. Now, the basic layout in drawings isn't too different from what you've seen in parts and assemblies. However, if you look at the Feature Manager design tree, you'll notice a few key differences. It's much less populated. You won't see planes or the origin here. Instead, you'll find only 2 main items, the Annotations folder and Sheet 1. And if you expand Sheet 1, you'll see more items inside. But we'll save that for another time. If you right-click on Sheet 1 in the Feature Manager and select Properties, you'll open a dialog box called Sheet Properties. Here you can adjust almost everything about your drawing sheet, from the scale and sheet format size to choosing between first angle and third angle projection. This is important to know when you need to change global sheet settings. For this tutorial though, we'll keep things simple and leave all things as they are. Now let's take a look at how you can edit the borders and the title block of your drawing. To do this, right-click Sheet 1 again and choose Edit Sheet Format. This will turn the border lines black, the title block blue, and you'll see a symbol appear in the top right corner of your drawing window. While in this mode you can make changes to both the border and the title block. Let's start with the title block. It's essentially a collection of lines and notes already built in the sheet format by SOLIDWORKS. You can highlight, select, delete, copy, paste, and of course edit these elements like the text I've copied here. When editing text, yellow guidelines appear to help you center it. If I wanted, I could delete, copy, paste, or even draw new lines using the Drawings tab in the Command Manager, but I'll leave the title block as it is for now. Next, while Edit Sheet Format is still active, right-click directly on the sheet and choose Automatic Border. The PropertyManager will open with options for this command. For this tutorial, I'll start by unchecking Show Zone Dividers, which removes the internal lines between the numbered rows and lettered columns. I'll also hide the columns and rows entirely, removing the numbers and letters from the border. From here, I could adjust the border's distance from the sheet edges using the margin settings, or even switch between a single line or double line border. Then click the green checkmark to confirm. Once you are done with your drawing sheet's appearance, click the symbol in the upper right corner to exit Edit Sheet Format. You can also find all sheet format related commands in the Sheet Format tab on the Command Manager. It is important in the detailing process to produce the views you need. While it's possible to draw directly on the sheet, much like working in a 2D environment using the commands in the Sketch tab, that's not our focus here. Instead, we want to take advantage of the 3D models we've already created and use them to generate accurate 2D drawing views. So for now, we'll skip the Sketch tab and focus on learning the commands in the Drawing tab. And one of the best ways to start is with the standard 3-view command. This tool lets you either browse for a file or select one that's already open. You can also choose a configuration if the model has any. For this example, I'll use my Geneva wheel and select its only configuration. Once you click the green checkmark, SOLIDWORKS will place the 3 standard views onto your drawing: front, top, and right. You might also notice that the values in the title block have updated. These come directly from the model's custom properties that we've already inserted. Each drawing view is surrounded by a rectangular boundary. To move a view, click and hold the left mouse button when this border is visible. Then, drag it into a new location. The top and the right views are always aligned with the front view. This means that the top view can only move vertically and the right view can only move horizontally. The front view, however, can be moved freely anywhere on the sheet while still maintaining its alignment relationship with the other two. All drawing views also appear in the Feature Manager design tree on the left. When you left-click on a view on the drawing, the Property Manager opens, letting you modify that view's settings. For example, the orientation option controls which side of the model is displayed. When you change a parent view, that's the main view from which the other views are projected, the dependent views update automatically, just as the warning message explains. You can also control the display style here. The options are similar to those in part and assembly modeling. Changing the display style of the parent view will update the dependent views accordingly. Another important setting is the scale. By default, the Use Sheet Scale option is selected, which applies the sheet scale value to the view and the entire model. But you can change this to a custom scale, whether that's a realistic value or something unusual. For now, I'll focus on these options and click the green checkmark to accept any changes I've made. Next, let's look at the projected view. When you start this command, you select an existing view on your drawing. Then, by moving your cursor around that view, you'll see different projected views appear depending on the cursor's position. For example, moving the cursor between 12 and 3 o'clock produces an isometric view. For now, I'll press Escape to exit. To show you how to start a projected view by simply left-clicking the box of the front view and select the command from the context menu. Normally, when you click to place the projected view, it aligns automatically with the parent view. But if you want to place it freely, hold down the Control key while moving the view. This lets you position it anywhere you like. Then, left-click to place it, and from there, you can drag the view freely to adjust its position. As I mentioned earlier, changes made to the parent view affect all dependent views. However, if you select a dependent view, like this newly created isometric view, you can uncheck the Use Parent Style or Use Parent Scale options. This lets you choose different display styles or scales independently from the parent view. You can do this for any dependent view to customize it as needed. To delete a view, simply left-click on it to select it. Then, press the Delete key on your keyboard. A confirmation dialog will appear, asking if you want to proceed with deleting the selected view. You can add new drawing sheets within a drawing document, letting you include multiple sheets to display more objects. Keep in mind, any changes made on the sheet won't automatically apply to the new sheets. If you want that, you need more advanced techniques. Also, the active sheet is highlighted in the Feature Manager design tree, so you always know which sheet you are working on. Next, we'll use the Model View command. This command starts automatically when you create a new drawing, but you can also activate it anytime from the Drawing tab. I'll select another model, just like before. You'll see a preview thumbnail of the chosen model. Then, I'll click the next arrow at the top right of the Property Manager. A box appears where your cursor is, showing the viewport. On the left, you'll find the same options we've seen before, letting you control orientation, display style, scale, and more. Once you're done with the settings, left-click on the drawing to place the view. At this point, the Projected View command automatically starts, allowing you to add additional views by moving your cursor around, just like we saw in the previous Projected View section. I'll add another drawing sheet. This time, we'll use the View palette located in the task pane on the right side of your screen. From the top drop-down menu, you can select one of the models you already have open, or click the three dots to browse for any model you want. Once selected, all standard views appear, along with any special views you may have created during modeling, like exploded views. This method is especially useful when you want more precise control over which views to add. For example, I can drag in the top view and the exploded view here. Now that we have three sheets, it's a good idea to rename them. Right-click on any tab to open a menu with useful commands like copy, paste, delete, and of course rename. I'll choose rename to give these sheets more descriptive and fitting names. Let's dive deeper into creating more advanced but essential views, starting with a section view. As the name suggests, this command creates a section by using a cutting line. The cutting line can be horizontal, vertical, or in some cases more complex. I'll keep it simple and choose an horizontal cutting line. Clicking in the center of this view, a toolbar appears with more options, but I'll keep it simple and click the green checkmark to confirm. The Property Manager on the left appears, allowing you to modify the projected view. In addition to the familiar options, you'll find the Flip Direction button and the Auto Flip checkbox to change the cutting line's orientation. Notice how the view updates along with the section arrows. Like any other view, left-click on the drawing to place it. The section view automatically adds cross-hatching where material is cut through. This section is labeled as Section A-A. I'll create another section view on a different sheet, this time using a vertical cutting line. The label increments to Section B-B accordingly. At this point, it's important to know that you can break the alignment of a child view from its parent. Simply right-click the child view, choose Alignment, then select Break Alignment. Once broken, the view can be freely dragged anywhere on the drawing. To restore alignment or manually align one view to another, right-click the view you want and then go to Alignment. There are several options here. For example, I'll choose Align Vertical by Origin. Let's return to creating more views. The Detail view is important for zooming in closely on a specific area of another view. You start by drawing a circle around the area of interest in the existing view. Then, left-click to place the new Detail view wherever you want on the sheet. Once placed, the Detail view is automatically named and numbered in sequence. For example, this one is Detail View C. Detail views enlarge the encircled area but otherwise function like any other view, meaning they can be edited or deleted. For instance, I can increase its scale using the Custom Scale option to improve visibility. I've created another section view here to show you a different option, the crop view. First, I'll draw a circle inside the view by going to the Sketch tab. Once the circle is created inside the view's boundary, I'll switch back to the Drawing tab and select Crop View. When activated, Crop View keeps only what's inside the circle and hides everything outside it. Let's place this crop view next to the detail view and compare them. At first glance, they look similar, but there are key differences. Aside from the fact that the detail view displays an annotation at the bottom, the main difference is scale. When you create a detail view, it automatically scales up the area inside the circle. The crop view, however, keeps the same scale as the original view. If you want to revert a crop view to its original state, right-click in the Feature Manager design tree, go to Crop View and select Remove Crop. For now, I'll delete this crop view entirely. Let's check the Broken Out Section command. This command removes a portion of the model to reveal what lies beneath at a specific depth. It starts by drawing a spline that encloses the area you want to cut away. Using the Preview checkbox, you can see both the resulting cut and the cutting plane used for the section. The depth can be set either by entering a value in the dimension field or by selecting an entity in the drawing, such as an edge or a circle. Imagine you have a long but thin object. Displaying that in a drawing can be awkward since it looks mostly like a straw. The Break View command helps by creating a gap or break in the view by using a pair of break lines, allowing you to show large objects on smaller sheets more effectively. These break lines can be edited or deleted after placement. The best part is that reference and model dimensions related to the broken area still reflect the actual model values. Next, let's explore the Alternate Position View command, which works only with assembly views in drawings. I'll select the top view and from the Property Manager, choose New Configuration. Clicking the green checkmark takes you to the assembly model, where all components are positioned as in the chosen view. Here, the Move Component command activates, allowing you to drag components freely. For example, I'll use Physical Dynamics to move the index wheel from one spot to another. Once finished, clicking the green checkmark returns you to the drawing where the new position appears as dashed lines. So far, we've seen how to add views, but views are just part of a drawing. Without annotations, the drawing lacks essential information. The Annotations tab provides tools to add dimensions, notes, symbols, tables, and more related to your models on the drawing sheets. Let's start with Smart Dimensions. They work just like in part and assembly modeling. Drawings also offer special tools to ease detailing. For instance, if you select one of these half circles, SOLIDWORKS automatically places the dimension neatly beside it. You can do the same for arcs, circles, and even construction geometry. Clicking this arrow reveals additional options like Chain Dimension, which lets you add dimensions in sequence for a clean professional look, or similarly, the Baseline Dimension option, which creates all dimensions from a single reference point. You can switch between chain and baseline dimensions by right-clicking the selection. Lastly, the Ordinate Dimension option lets you set a 0 point for measurements, similar to baseline but anchored to a fixed origin. If you're wondering if you can use your dimensions from your model, the answer is yes, by using the Model Items command. This imports dimensions, annotations, and reference geometry from the model linked to the selected drawing view. You can import data for the entire model or just a selected feature. You might ask why use model items instead of smart dimensions or vice versa. Dimensions created by smart dimensions appear gray and are driven, meaning they only display values. dimensions imported via model items are black and driving, meaning they control the model and can be edited from the drawing. Both types are useful depending on your detailing needs. You can move dimensions between views. Simply hold Shift and drag the dimension you want from one view to another. This works with multiple selected dimensions too. By default, whenever a circle appears, you'll see crosses marking the center. These are center marks. They can be selected and deleted if needed. You can also manually add center marks using the centermark command by clicking any circle or slot. The Property Manager includes options like Propagate, which helps you apply center marks to patterns automatically. Similar to center marks, center lines can be added by clicking a cylindrical face or two opposite edges. Next, the Hole Callout tool adds driven diameter dimensions to holes made by the hole wizard or circular cuts. Using Hole Callout instead of many individual dimensions keeps your drawing neat by showing all hole information as one unified node. It works well even on isometric views. Nodes can float freely or attach to features with leader lines. They can include text, symbols, parametric info, and hyperlinks. Simply left-click where you want to place your node, type your text, and then left-click to place it multiple times as needed. Most of the times, assemblies need a bill of materials to track all components and key information. Select an assembly view. Then, from the Annotations tab, under Tables, choose Bill of Materials. You can use SOLIDWORKS default BOM template or your own custom BOM. I'll select a custom BOM and click the green checkmark. The BOM table attaches to your cursor. Click to place it anywhere on the sheet. If you check the Attach to Anchor point before inserting, the table snaps to the top left corner and stays anchored there. The rows and the columns fill from the model's custom properties. Each part gets an item number, and the QTY column, which stands for quantity, counts how many times the part appears in the assembly. But to complete this view with the BOM, we'll need to add balloons. The balloon command lets you add balloons manually, which is useful if you miss some or want precise control. Use Auto Balloon to automatically insert numbered circles referencing the BOM item numbers next to the components. You can adjust the balloon layout or drag balloons freely for clarity. Auto balloons come with magnetic lines, guides that align balloons along a line at any angle. Hold the left mouse button to rotate or move the magnetic line. You can add multiple magnetic lines using the magnetic line command and attach balloons by dragging them onto these guides. Magnetic lines don't appear when printing. Now that we have our balloons, let's further modify the BOM. You can add columns to the BOM by right-clicking a column header and choosing Insert, Column, Left or Right. Once inserted, type freely like in Excel or choose a custom property from the drop-down, such as Material. If your components have those properties filled, they automatically show in the BOM. You can resize rows, columns, and the whole table as you would in familiar Office software. Finally, now that we're done, let's save the drawing as PDF. SOLIDWORKS drawings use the SLDDRW format, which requires SOLIDWORKS to open. Exporting as PDF lets anyone view your drawing easily. Select PDF as the file type. Click Save. A PDF export dialog will ask which sheets you want to include. This lets you export only specific seats if needed. Click OK to finish. Open the PDF with a viewer like Adobe Acrobat Reader. Depending on your viewer, the seats appear as bookmarks, letting you navigate views, bombs, balloons, etc. And that wraps up this general tutorial on SOLIDWORKS drawings. Remember, this is just the beginning of your journey. There are many more commands and secrets to explore as you work more with drawings. If you found this video helpful, don't forget to hit the like button and subscribe to my channel for more SOLIDWORKS content. I'll see you in the next video.